Well, now you've mastered the part whole bar models, so let's move on to comparison bar models for addition and subtraction. So again, we read through it, make sure we understand it, and then we start with our bars. So 305 children go to the zoo on Saturday. 278 more children go to the zoo on Sunday than on Saturday. So I know I'm comparing because it says more children go to the zoo on Saturday than Sunday. How many children go to the zoo on Sunday? Well, I'm of course going to start with my answer sentence. Children go to the zoo on Sunday. And again, I go back and I reread and I start my bar modeling. So I know 305 go to the zoo on Saturday. So I might even put in SA so I remember that that's Saturday. Now, 278 more children go to the zoo on Sunday. So I'm comparing them because I want to see how many I know how many more go on Sunday. So I'm going to make my bar for Sunday, and I know it's more. So I'm going to make it longer, Sunday. I don't know how many went on Sunday. That's what I'm trying to find out. But I do know how many more went on Sunday, so I can dot that in, and I can put the difference in. The difference is 278 more go. So clearly when I look at this, I see this is the biggest piece. So what do you do when you're looking for the biggest piece? You add. So I would do 305 plus 278, 13, I regroup, 8 tens, and 5 hundreds. So I circle my answer, equals 583, and then my students would be checking it with the inverse operation. And again, hopefully they would come up with 305, but for time's sake, I'm not going to do that for you. And I can put that in my answer box because it looks reasonable. It should be the biggest number, and it is. 583 children go to the zoo on Sunday. So again, we're comparing two quantities, and that's why we're choosing the comparison bar model rather than the part whole. Next one, Sue has 402 rocks in her collection. Jim has 123 fewer rocks than Sue. How many rocks does Jim have? Jim has rocks. And again, I start rereading and I start my bar modeling. So I know this is Sue, and I know she has 402 rocks in her collection. Jim has 123 fewer rocks than Sue. So this time I'm going to make Jim's box, but it's going to be shorter because Jim has fewer. I don't know how many he has, but I know how many fewer he has, so I can do the more than less than box, which is 123. And again, looking at this, I can clearly see I have my biggest part. So if I want to find one of the smaller parts, then what do I need to do? I need to subtract 123. And again, some regrouping here. 9, 7 tens, and 2 hundreds. 279. My students would circle it. They would check it with the inverse operation, 123, add that back in, and they should get 402. And then you put it back in your answer sentence. So 279. The reason why we circle this is so we don't accidentally put what we rechecked for in there. It stands out to us, and we could look back here as well. The third one says Josh has 428 Lego pieces. John has 500 Lego pieces. How many fewer Lego pieces does Josh have? Josh has fewer Lego pieces. And the fact that I'm saying fewer should cue into me that I need a comparison bar model. And I'll reread. So I'm going to start off with Josh, and he has 428 Lego pieces. John has 500 Lego pieces. Well, that's more than 428, so I'm going to make his bar bigger. And that's John has 500. And so I want to know how many fewer Josh has. That's this piece right here. And again, I'm looking at it. I know this is the biggest piece. So if I want to solve for one of the smaller pieces, I know I have to subtract. 500 minus 428. And there's some more regrouping. 9. And let's see, 10 minus 8 is 2, 7 tenths. So 72 is my answer. I make sure that makes sense, and I can put it in my answer sentence. And of course, I'm going to check it with the inverse operation. And I would get 500 when I do that. So that's when we're using the comparison bar model, because we are comparing two quantities and either solving for the difference or solving for one of those quantities. Thanks a lot. Next one, we'll talk about using bar models to solve two-step problems.